neighboring particles, so atoms, molecules, or ions. They are weaker than intramolecular forces. London dispersion is one of these forces. It is the weakest attractive force between molecules. All matter experiences London dispersion. It is when the nucleus of an atom is attracted to the electrons of the other atom in a molecule. So, nucleus 1 is attracted to nucleus 2. An induced dipole, which is what the example above is created when two molecules are in the presence of one another. A dipole is just the separation of charges within a molecule between two covalently bonded atoms. In order to show that a molecule is going through London dispersion forces, we must first understand polarity. A polar molecule is a molecule that contains a distinct positive and negative region due to the presence of polar bonds. For example, H2O. So first we have to find out what hydrogen and oxygen's electronegativity is, and we can find that on the periodic table here. So hydrogen's electronegativity is 2.2 and oxygen's is 3.4. And electronegativity is just the measure of an atom's tendency to attract the bonding electrons of another atom. So oxygen has a higher electronegativity than hydrogen. Therefore, hydrogen's bonding electrons are more attracted to oxygen's, and we show it with these arrows. Because hydrogen is sharing its electrons, it gets a positive charge, and oxygen gets a negative charge. You can see that there is a distinct negative and positive region. That means this particle is polar. We just show it with an arrow like that. So this region is negative, and this region is positive. When a molecule does not have a clear positive and negative region, it is nonpolar, but it will contain polar bonds if each atom has a different electronegativity. For example, CH4, and that's how it's drawn. So hydrogen's electrons are attracted to carbon's, and you can see that all around carbon is negative, have positive charges, and then carbon has a negative charge, and there is no distinct positive and negative region, so it's nonpolar. What impact does London dispersion have on physical properties? The answer to this is boiling or melting point. This is because the higher the difference in electronegativity, the stronger the bonds between each atom. For example, carbon dioxide and water. Carbon's electronegativity is 2.6. Oxygen's is 3.4. 3.4 minus 2.6 is 0.8. So that's their difference in electronegativity. You do the same thing with water, and you find that hydrogen and oxygen's difference in electronegativity is 1.2. Therefore, water has stronger bonds and is harder to break apart. So, water has a higher boiling point than carbon dioxide. What affects the strength of London dispersion forces? First, size. The larger the molecule, the stronger the London dispersion forces. Remember, size is determined by the number of protons and electrons in an atom. For example, CH4 versus C3H8. CH4 has 10 protons, and C3H8 has 26 protons. So CH4 has 10 electrons, and C3H8 has 26 electrons. Therefore, C3H8 is bigger, so therefore it has stronger London dispersion forces, and therefore a higher boiling point. Secondly, their shape. The greater the surface area contact, the higher the London dispersion force. Therefore, the greater the surface area contact, the higher the boiling or melting point. For example, so this shape has a larger surface area than this shape. So this means that this shape has a higher London dispersion force than this one. So this one has a higher boiling or melting point than this one.